Today we're going to look at independent events. And the learning goals for this lesson, and we're going to be able to determine whether two events are independent or not. So two events are independent if the outcome of one event does not influence the outcome of the second event occurring. So that means that the probability of A given B is going to be exactly the same as the probability of A occurring. So for example, if I flip a coin and I get heads, that does not affect if I flip the coin again. I've still got an equal chance of getting heads or tails. So the chance of getting heads or tails on the first go is exactly the same as chance of getting heads or tails on the second go. This is a really important thing to understand, because it can be taken to or the opposite kind of idea is that maybe they are linked. Maybe the probabilities of flipping a coin are linked, and it can be something called the gambler's fallacy. But if I get heads hundreds and hundreds of times in a row, by sheer chance I get heads 100 times in a row, that the next one, there's a higher chance that the next one will be tails. But that's not true. If I'm flipping the coin and I get heads 100 times and it's a fair coin and it's a normal coin, then on the 101th time the chance that it'll be heads or tails is still 50-50. So this essentially, this is our definition of independent. Independent events are events that are not affected by any other, by an event occurring. So the probability that A given B is exactly the same as the probability of A occurring. So that means that we can actually calculate the probability of the intersection of A and B with independent events. So for independent events, the probability of A, the probability of A and B occurring is going to be the probability of A multiplied by the probability of B occurring. So multiple events with replacement are independent. So that's when we're talking about rolling a dice and then rolling the dice again, or flipping the coin, or flipping the coin and flipping the coin a second time. If we replace it, so if it can turn up again, then those events are independent. They're not going to be affecting each other. But if we have replacement, then they are not going to be independent, because that means that by not replacing something, we're changing the outcome for the next set, or the next event that we actually have. So if we have a look at an example here, we've got a selection of 10 mobile phone offers. It includes 4 with free connection and 5 with a free second battery. One of those offers has both free connection and a free second battery. It says use a Venn diagram to aid in your explanation. Determine whether, using a Venn diagram, determine whether or not the events free connection and free second battery are independent. So let's have a look. We'll draw up a Venn diagram here of the two events. First event here, second event here, and the event on the left we'll call free connection, so we'll call it connection, and we'll call second battery B for battery, so connection and battery. So it says we've got a total of 10 mobile phone offers. There are 4 with free connection and 5 with a free second battery. One has both, so there's 1 in the middle here. 4 have connection. 4 have free connection, so that means 3 plus the 1 is going to be 4, and 4 plus the 1 is going to be 5 that has the free second battery, and that means that we've got a total of 8 there. There must be 2 that have neither free connection or free second battery. So we've got our Venn diagram drawn up here. If we have a look at now determining whether or not the events free connection and free second battery are actually independent, we need to compare the probability of one event occurring. So the probability of, say, event C occurring, that's going to be a probability of 4 out of our total probability of 10. Okay, that's going to be 2/5. Probability of our event free connection occurring. And we also need to have a look at the probability of C occurring given that B has already occurred. And if they are the same, then that means the probability is going to be the same. So the probability of the free connection, given that the second battery occurs, if we just have a look at B, that's a total of 5 and we have 1 being the intersection of both, 1/5. So 1/5, that is not equal to the 2/5, so it's not equal to the probability of our second battery actually occurring. So it means that therefore our events, the events, are not independent. Because if they were independent, then the probability of the free connection occurring, given that the battery, that there's already a free battery, would be the same as the probability of the free connection happening just by itself. So if we think about our learning goals for this lesson, what we're looking at being able to do is determine whether or not events are independent or not. And events are going to be independent if their outcome is not affected, or the probability of that outcome happening is not affected by any other previous outcome occurring.